Hello all, welcome to the next video in the video series on DIP lab through Octave. In this lecture, we will discuss the implementation of Laplacian filter. So to implement Laplacian filter, we are going to use two functions that we will discuss first, and then we will go to the script where we will write code for implementation of Laplacian filter. So let's first clear the workspace since some of the variables are already present in the workspace. So I'll clear them. So the command is clear all. Clear, clear all. We clear the workspace. CLC. So the the first function which we are going to discuss is fspecial. So the function name is fspecial. So what I will do, I will first show you the help of that particular function. So this is the function. Let's help. Let's explore. So now you see this f special function is used to get the filter coefficients of different filters. Like here we have the uh, the use of f special to have the filter coefficient of average filter. So by using this expression in this form, we can get the filter coefficients of averaging filter. Similarly, some different filters are there, like the disk is there, Gaussian is there, then this log is there, then Laplacian filter is there. So this is of our interest. So how do we get the Laplacian filter coefficients using f special function is, so we have to use the function f special with the input argument Laplacian. So this Laplacian will go as a string, as a string as the input argument. And then we have another option to use this f special function in which we pass another argument to, that is alpha. Now alpha is numeric value, and how alpha is related to the coefficients is this way. That means these coefficients we will get if we give the value of alpha 2, then 4 divided by alpha plus 1, this is multiplied by this matrix. So this 3 cross 3 matrix we will get as the output. If we do not use any value of alpha, then by default value of alpha is zero point 0.2. By default value of alpha is 0.2, and we can vary alpha from in the range 0 to. So this is how we are going to use this f special function to get the coefficient of the Laplacian filter. So let's explore this. I will just clear the window, and let's try to find out the uh, coefficients of Laplacian filter. So here f special Laplacian. And if I pass this as input, you see this is the default value which we get for the alpha zero point 0.2. Now if I want this filter as 0 1 0 0 minus 4 0 and 0 1 0, that form, then alpha value will be 0. So if I pass along with this the alpha value also, that is 0, so we get this filter coefficient. So by changing the value of alpha, we can change the filter coefficients of Laplacian filter, and we can use this function to have the filter coefficients of Laplacian filter. Now, the another function I want to discuss is imfilter. So let's check out its help. Imfilter. This function we use when we have to apply filter on an image, then we use this function. So what is the default argument which we pass in the imfilter function? That is the input image on which we want to apply the filter, and the filter coefficients which filter which we want to apply. That filter coefficients we have to pass as the second input argument. So these two input arguments are mandatory, and some optional input arguments are also available in this function. So let's explore these optional filter coefficients. Sorry, the function arguments, input arguments. So here, these optional input arguments are for the type of padding we want to have in the input image. So this padding we already have discussed in the implementation of spatial domain filtering. So there, which type of padding we want to use, that depends on the third input argument, right? So if we pass a constant that is scalar, then that will be padded as the that will be used as the padding for that particular function. Then these are the options which we can use for the padding. And then which type of filter we want to apply, that means we want to apply it with correlation operation, or we want to apply it with convolution operation, that also we can mention in the uh, as the input argument. So this way we can use fspecial. So here two arguments are mandatory, then other arguments are optional. In optional arguments we have arguments for padding. So these options are for padding, and two options for relation CORR, that is for correlation, and CONV, this is for convolution operation. We pass we are these are the optional parameters which we can pass as the input argument of this function. Hope this is clear. Now moving forward, now next we have, let's try to apply this filter on some image. So let's get an averaging filter. So that I will get into variable w. So I will get it using fspecial, and then average. So fspecial and average. So here we can see this is 3 cross 3 by default, 3 cross 3, and all the elements are 1. And in averaging filter, we remember that in outside it is multiplied by 1 by 9. So 1 divided by 9 will become 0.1111, and so all the elements will become 0.11. So I in this I read one image. I am read, and this is camera man dot jpg. So I get this image into I, and then I can apply it and averaging filter on this. So that will be I am filter, and the first is I, and the filter coefficients are in W, and I want the um, heading of replicate type. That means the last row and column will be replicated for the heading. So this is our output. I will show this. I am show, and I show the output. So you see, this is the averaged image, cameraman image. So you see, when we use these functions, we need not to worry about the class of the output image. Here we did not change the class of the output image from double to unsigned int 8, because by default we will get the output image class as unsigned int, since we are using the functions which are special for the images. So this function is for image filtering. Let's move on to the implementation of this Laplacian filter. So uh, let's start writing the script for this. So first we write CLC clear all, close all, close all. Okay. So now I will read an image. I am read that I will read into I variable, and I will read the moon image that I have downloaded from internet and stored into my directory. So here you can see my directory is on desktop lab b3, and these are the files which are there in the directory. And now I read this into the variable I. Then what I will do, I will take the coefficients, filter coefficients, into the variable w. So for that we use the function fspecial. Fspecial, inside this I will pass the input argument. One is Laplacian, since we want the Laplacian filter coefficient. So I will pass first argument as Laplacian, and I want those basic uh, coefficients which are 0, 1, 0, and 0 minus 1 minus 4 1, and 0 1 0. So for that alpha is 0, so that I will use here. And then we will apply this filter coefficient on the image. So for that I am filter, and then I apply the W filter coefficient on this, and the padding I use here is replicate type. Replicate. So this I will do. And now you see, to enhance an image using Laplacian filter, what we need to do, we need to subtract the filtered image from the original image. So by subtracting the filtered image from the original image, we will get what? The enhanced image. So enhanced image will be O1, that is equal to I minus O. I minus O. So that will be enhanced image. So this is it. This is how we can enhance the image using Laplacian filter. I will display all these three images. So I am so to load to display these three images on the same figure window, we use what? Subplot. Subplot. So I will divide the figure window into one row and three columns. At first position, I will display the original image. So for that, I am so I, and its title I will give what? Original image. Original image. Copy it. At second position, I will display what? The filtered image which we have got into the variable O. So this is filtered image. Filtered image. And then at third position, we will display the enhanced image which is there in O1. So it is enhanced title I have given. That's it. It is done. Let's run this. So we got an error. Let's check it out. F special, some error is there. Laplacian. Laplacian spelling we have not written correct. So it is Laplacian. Sorry. So this is the mistake. We have to give the proper input argument. So Laplacian spelling is Laplacian. So this spelling we have to use. Let's run this. Then some error is not supported. Oh, sorry. Again, Laplacian. No, it's done. So this is the original image. This is the filtered image. So here we can see the filtered image using the Laplacian filter will give us the edges which are available in the original image. So this is an edge, so that is quite clearly visible, and here also some edges are there that are available here, that are visible here. Now when we subtract this filtered image from the original image, this we get the enhanced image. So here we can clearly see the edges are clearly visible. These edges are also enhanced. Here we can see this dot is clearly visible now. These edges are also enhanced. These edges are also enhanced. Here also this can be seen that here edges are clearly enhanced. So this is how we can implement Laplacian filter, and we can use this Laplacian filter in image enhancement. That's it for this lecture. We will meet in the next.